All right, so welcome to this short video where we're going to talk about the marginal revenue that monopolies can earn from selling more units. And this is going to be important, obviously, because monopolies, like all other firms, use our MR equals MC condition to maximize profit. So we're really going to need to understand the monopoly's marginal revenue before we can understand how they're going to maximize profit. And our starting point for today, for sake of comparison, is that, remember, for perfect competition, the marginal revenue I earned from selling an extra unit for P dollars was just P dollars, whatever that price was. That's not going to be true for monopolies, and we can see that two different ways. First, we can look at the geometry of the demand curve monopoly faces, and second, we can do a numerical example. For some people, one way or the other is going to be more clear. Hopefully both ways help you to understand the relationship of M, R, and P, but we'll go through both ways just in case. All right, so let's first look at the geometry. We could imagine that the firm is initially selling at a price that I'll call P1, and it's selling Q1 units, and this box basically represents the revenue. We saw this when we studied elasticity. P1 times Q1 gives us a rectangle with the area represented by that box, so we can think of that as our revenue. Then we could imagine adding one more unit to our sales. So we'll sell Q1 plus 1 units. That'll move us to a point like B. And the first thing we notice is that now our rectangle for revenue is 1 unit wider, so it's a wider rectangle, but in order to sell that extra unit, we had to lower the price. That's not something that a price taker had to do because they took the price as fixed. So this is the real main difference between a monopoly and a perfectly competitive firm, a price taker. And now if we look at the geometry here, we can see that in going from Q1 to Q1 plus 1 units, we picked up all this light blue area in revenue, right? Our box is wider, so we've picked up some new area, and specifically it has a width of 1 for that one extra unit and a height of P2. So we picked up P2 extra dollars, and P2 is our current sales price, so we could just call that P. We picked up P extra dollars from selling one more unit. The problem is, as we noticed before, we had to lower the price on everything we're selling, and that causes us to lose all this dark blue area in revenue. So we've gained some revenue, the light blue, but we've lost some revenue, the dark blue. And in summary, we can say that since we gained P dollars from light blue and we lost some dollars from dark blue, whatever the net increase, the marginal revenue was, it's going to be less than P2, less than the current sales price. So that's one way of looking at things. The other way we can look at things is numerically using a table. And the nice thing with the table is, unfortunately, it's going to have to be very specific, right? We're going to focus on a specific demand curve represented by these quantities and these prices. It's the line 10 minus Q, P equals 10 minus Q, if you were interested. But now we can be very specific and go ahead and calculate the revenue and then calculate the marginal revenue. So P times Q, our revenue is going to be 0 when there's a quantity of 0. That makes sense. $9 when we sell one unit for $9, then 16 and 21. As we sell more and more, we get more revenue. But what we notice is the marginal revenue is declining. For the first unit, it was $9. Then we added $7. Now we're down to $5. So in contrast to with perfect competition, we notice a definite trend that for perfect competition, marginal revenue is fixed. It's just P dollars, whatever that P is. Here it's a declining function of Q. As we sell more and more, we get less and less marginal revenue. If we went on forever, as you'd probably guess, eventually the marginal revenue would go negative. We can only get so much revenue before we start actually losing and decreasing our revenue. The other thing we notice is, for all except the first unit, when we compare price here, $8, to marginal revenue here, $7, the MR is lower. Price here, $7, MR here, $5. For the first unit, it's 9 and 9, so they're equal. So ignoring that first unit, which is kind of special, we can make the general conclusion, and this is correct, that for a price maker, for a monopoly, the marginal revenue is going to be below the price. And that's basically what we said earlier with the geometry. So I'm going to write this in next to perfect competition. For any monopoly, MR is less than P. And if we go back to the geometry, it'll help us to understand why, for the first unit, the marginal revenue and the price match. The reason is that you get P dollars, whatever the price is, from selling that one extra unit. So that's where we get 9 from. And then normally we'd have to subtract out some from lowering the price on previous units sold. For our first unit sold, there were no previous units sold, so we don't actually have to subtract anything from 9. We get $9 from selling one unit, subtract nothing from lowering the price on other units, so our marginal revenue for that first unit is 9. But in contrast, for our next unit, we get $8 here. The price is $8, but we have to lower the price on the first unit from 9 down to 8, so we lose $1. So our net is going to be 8 minus that $1. 8, the blue area here, the light blue area, minus 1 from losing the dark blue area, and our net is 7. All right, so finally, if I went ahead and calculated my marginal revenue for all these different units, and I went ahead and plotted them alongside that demand curve, we'll see this, which is a fairly typical relationship. The demand curve started at 10, has a slope of -1, so it goes down to 10. If I plot out the marginal revenue curve, it also would start at 10, but you can see it declining much faster. It actually has twice the slope, so it goes down twice as fast. So here's my demand curve. This is my MR curve. So it would intersect on the Q-intercept at 5. That is a typical relationship. The more important thing being the MR curve is below the demand curve. That's what we meant when we set up here, MR is less than P. Demand indicates the price, MR is less than that, so geometrically it's below it. The other thing is that because demand is a complete straight line, the MR curve just has twice the slope. But that's not particularly important because that's unique to just these situations where we have an exact straight line, which is probably not going to be too common in real life. So that's a summary of marginal revenue for monopolies. There's lots of other short videos on firm behavior attached in this playlist. If you're confused about a particular topic, go check those out.